Hi, I'm Elinor Rubin-McGregor. I'm a graduate student at the University of Kentucky, and as said, this is Generalizing a Numeric Personality Metric for Narrative Planners. So, as the name implies, this presentation is a lot more about narrative planners, that is to say, the concept of creating a narrative or planning a narrative, possibly during a story, so in the middle of generation. Uh, so, um, some of the ideas that we're talking about here specifically have to do with personality, because as many of you know, when you're creating a story, having consistent character personalities is kind of important. It really helps the audience engagement in a lot of ways. And there are several existing personality models with narrative planners, but there's some things about them that make them a bit unique. Some of them, like for example, Versu, are either very specific to a certain circumstance. For example, in Versu's case, what happens is you only are really modeling the personality of the actor or of the main character, and the audience's actions are what determines that. Others that are pretty well advanced, like Kami Il Thought or Why Are We Like This, have to require large sets of information, social facts databases, libraries of social interactions and such, which, while that's interesting and produces very strong results, has the downside of requiring and demanding a huge amount of work. If you're trying to tell a story that may not fit into a domain or may not fit into the social facts database that already exists, then you have a problem there. You either have to do a lot of work or you can't use these systems. So, what we're working on here is trying to make a simple number-based personality metric that works basically with any possible domain that you can think of. So the reason why we think this is important, one is that having a simpler personality metric, you can use that then in comparison tests. A lot of people, when they research on personality, they only can report on their own because other personality metrics, you can't really fit it to the same environment. Having a simplistic one may not be the best personality for a story, but it does give you something else to compare your work to. Another reason to have this would be if, say, your work is on something where personality is useful but not central. You can use it, having something simple that can be applied to any system could be a useful add-on. Also, if you're trying to, say, work on, say, personality systems in general, or some larger aspect of this field, having simply something simple to add on, again, can be a useful tool for that environment. So what we worked on was the ocean model designed by Shivani and Ware in 2019. This was based on the Big Five ocean personality model. The way it worked was it essentially produced a set of 12 different sort of metrics or values that could be measured and mapped out to collectively analyze how well a given action during a story matched up to each personality trait or attribute. The idea being that, let's say we have a story with an NPC. We want an NPC to do this action. Well, let's measure how well this action matches up to the personality traits and then see if that is close enough to the NPC's personality. For example, let's say your character is Santa Claus. Let's say for whatever story you're planning, you're trying to get it to a certain point. You can have Santa Claus give someone a gift, or you can have them yell at someone. Between the two actions, Santa Claus, based on his personality, would probably lean more towards giving a gift. So having that information can be useful. For those who aren't familiar with the ocean personality model, again, it basically tries to break down personality into 5 values, why it's useful for small scale stuff. The first is openness, as an openness to new experiences. This was defined as creativity. Shivani and Ware also tried to define it as a form of intelligence, likeliness to succeed. Next is conscientiousness. Essentially, you can think of this as sort of neatness or well thought out planning. One of the attributes listed here, and you'll notice anything with an R means it was measured in reverse, is essentially saying the length of a plan in reverse. So smaller plans were considered more conscientious. More complex plans are less conscientious. Next is extroversion, which is essentially how much a character wants to interact with other people. if you're working with a very specific type of scenario where you're working with a player playing the game, you could probably focus this towards player interactions. But extroversion should not be mistaken for agreeableness, which is how much a character considers the wants and needs of another person. Say you have, for example, a character who is very manipulative, very self-centered, but very good at getting other people to do things that will hurt them and benefit that character. The character would have high extroversion, but low agreeableness. Lastly, neuroticism, which is more emotional. There's only one score here. It is essentially how emotionally stable a character is. The table on the right-hand side that you see here lists off the 12 metrics that Shivani and Ware created, as well as which personality attribute they map towards. Most of these are pretty straightforward, and you can get in a lot of narrative planners, in a lot of story generations. However, there are some problems. 3 of these values, the minimum action likelihood, which was used essentially to reflect a form of creativity, the probability of success, which was used as a form of intelligence, both apply to openness, and finally, the conflicts with other characters, which was used as part of agreeableness. These 3, so a few things to note. When we are describing occasions, that function there or occurrences rather, that determines how many times a given action shows up in a given plan. You'll notice that there's two numbers or two sums that they value over, n and m. This is part of where these things have problems. The problem with this is that while m is the length of a whole story or a whole plan, n is a set of all plans or a set of multiple stories. This works for some setups. However, as mentioned, sometimes the story generator that you're working with can only produce one plan at a time, especially if it's interactive, or sometimes when you're working with graph plans, you don't have enough room or enough computation power simply to calculate out all the possibilities. So that actually makes all 3 equations for many different situations or for many different setups, they're completely inviable because we simply cannot or don't have the space, don't have the time to evaluate every single plan. The other problem, however, is that conflict, as defined in this paper, is going to be essentially a sum over a set of plans with 1 for each conflict created for another character. Again, remember these metrics are evaluating how much a given action evaluates. So if this action creates conflicts for other characters, that increases it. The problem with this definition is that it's if it can create any conflicts. And the problem with that means that we need to also calculate all possible events that could happen after the given action. Some systems, this is calculable. However, some systems, it's calculable, but only with great error, and others, or only with great effort, rather. And others, especially ones where you're interacting with the player as you're going along, you really can't calculate that at all. So this gives us essentially a few problems. So our work was on trying to simplify these equations, and we tried to keep them as close to their original values as possible to see what we could come up with. Oh, sorry, that was the back button, not forward. Here we go. So for conflict, we essentially decided to redefine it a little bit by shortening the distance for which it looks, or for which it looks for a character's conflict. The assumption is that whatever system you're using, other characters, other NPCs, or the player, there's got to be some way to estimate whether they're happy or not with a decision, whether their goals are met or not, so on and so forth. So we essentially shortened it to see if the result of an action in question would directly conflict with other characters. If that action itself causes problems for other characters, then there's a conflict. We don't look beyond that, essentially, again, to shorten the view that we're looking at. For a revised minimum action likelihood, the idea behind this was originally to try and see how many unique actions a character takes. We tried to limit this to look at only one plan, that is to say the current one, and possibly any future steps if you have a system where the character can make a plan for future steps, in which case we'd be looking at the character's plan. So the way we did this was we created a set with all zeros, each index of the same size as the number of actions in the domain, and each index in the set would then relate to a possible action in the domain. We then would go over the entire story, meaning all the actions planned up that have happened up to the action that we're checking for, as well as, again, if there's a future plan, future actions planned out. We would then add to these sets in the indexes indicating for the action. So let's say we have a story that involves 3 different occasions of talking. For whatever index that talking is, that number is going to be 3. To actually get a numeric value then, we simply calculated out the variance of this set. So in that way, the idea is to evaluate how much variety are in the actions of the characters, or rather, how much this character's actions differ from the actions of themselves and others in this given moment. For probability of success, we notice that the 2 equations are very, very close, one being, or rather close to an inversion of each other. So we decided to do that quite literally. We decided if we're going to be calculating conflicts for other characters already, we simply take that value and invert it in order to get probability of success. Pretty simple fix. Again, we were trying to keep it as close to the original as possible. So to test this, we of course ran human tests. We tried to keep these as close to the original test domain as possible. There were some problems. We did not have access to the same story given exactly. So it was the grandmother one that was mentioned earlier, but we did get it as close as possible. We also, because we were only changing 3 metrics, which are basically 2 different ocean attributes, we then only ran tests for 2 ocean attributes. So the way this worked was when a subject was clicking on to do our test, they would go to one of 4 different random and invisible to them which one it is, surveys, each of which is essentially focused on a specific attribute. That is to say, the main character of the story that's generated is picked for, or rather reported by our metrics as having this attribute either in high degree or low degree. High openness, low openness, high agreeableness, and low agreeableness were the 4 tests. The way this worked was we actually started by showing them 4 different stories. One that matched the given metric. So again, if this was a high agreeableness test, they'd be shown a story where the character has high agreeableness, and one that inverted it. So again, for the high agreeableness test, they'd be shown a story where the main character shows low agreeableness. One where that metric was in the mid-range, and one where that metric was random. The idea behind this was to give the audience an idea of, hey, here's some things that's possible. Just a reminder, the character could be crueler, or they could be kinder, or they could be less creative, or they could have been more creative. Then we would tell the audience that one of these stories was the quote-unquote true story. We have an image up here showing what that shows. They were then told to answer all questions based solely on the true story, to ignore the other 3. Essentially, again, because the idea there was that the other 3 were just there to give them some ideas of what was possible. So as with the original tests, we had 2 different ways of testing it. First, we would give them a set of statements and ask them to rate these statements on a 5-point Likert scale rating, from strongly agree, neutral, disagree, strongly disagree. These statements were also taken from the original 2019 paper. There was a few changes to a handful of questions because of the domain. I mentioned that we based ours as closely as possible, and it was the grandma domain. If you recall, it was mentioned in a previous talk, the grandma domain has the framework that your main character, Tom, is trying to find herbs for his sick grandmother. We did not actually have the character of grandmother in our test domain. She's not a real character, but we mentioned it to the audience in the description of the system. We found that when we did that, they had a frequency to raid Tom and did the exact same statements. They had a tendency to rate some of Tom's actions as more agreeable, until we specified to exclude the grandmother, as she wasn't a real character, at which point we found slightly more accurate, or somewhat different results. So as mentioned, with a few minor tweaks, all statements were taken from there. We took all the statements for the attribute that was mentioned. So for openness, we had them rate all the statements for openness, but we also included one statement for each of the other 4 ocean categories. The idea behind that was, again, to get the audience to sort of focus, to sort of get the subject to sort of think about varieties or different options, or rather to keep them from hyper-focusing on one thing. The other format of data collection we had was story generation. So for this, we had like we sort of expanded the domain a little bit, told them it was expanded, and then gave them 4 more stories, which were, again, one was rated highly to the same attribute, one rated the opposite way, one random, and one in the middle. The idea there was that if the subjects were then asked to select which story they thought was most likely given the main character's personality, if the subject selected the same one that matched the attribute, that was considered a success. So for our test results, well, when combined, you can see that we actually did a bit worse than the original test when it came to the openness tests, but a fair bit better when it came to the agreeableness. Reminder that those E negatives mean that we are, in fact, in the decimal places, and p-values are measuring error. When we break them up into individual ones for high openness and low openness and such, we get the same results. So the conclusions that we have is that while agreeableness works a bit better, openness does not. One reason for this could be, of course, that agreeableness in the short term, if your immediate actions don't cause problems, that tends to look like you are considering things. But when it comes to things like probability of success, when you're looking, that really, you do have to consider if actions are going to cause problems in the long run, because otherwise, if you have long-term opposition, it doesn't really reflect if your actions right now are smart or not. Likewise, what we think happened with our other metric is that by measuring out in unique actions within a specific thing, we think that rewarded having a variety of actions, a variety of different actions in your plan, but not necessarily unique actions for solutions. That is all we have. Are there any questions?